Alright, thanks for watching. And today I would like to give you an interesting example of a case where the limit of the product of two matrices is not equal to the limit of literally the product of the limits. A to the n, and limit n goes to infinity, b to the n. So, in other words, matrices definitely do not behave like calculus functions. And by the way, why is that true? Because think of ab to the n as a very high power of ab. So ab to the n, that is equal to ab, that the n times. But a to the n times b to the n, that would mean this thing. And it's very important. So matrices do not commute. So in particular, it's not true that you can just rearrange this to get this. So heuristically, it's probably not true that in the limit, those two are, probably not true that they're equal in the limit. Okay, and here's a very nice example. It gives you a little bit of an ugly result, but I can modify this at the end if you want. Take A to be the following matrix, so 1, 1, 0, 0, and B to be the matrix 1, 1, 0, 0. And here's the cool thing. Usually to calculate powers of matrices, you have to diagonalize A and use A's PDP inverse and take D to the limit. Fortunately, we don't have to do any of that because it turns out powers of A are very easy to calculate. A squared, that's AA, which is 1, 1, 0, 0, 1, 1, 0, 0. And if you calculate this, you get 1, 1, 0, 0. So in other words, if you calculate A squared, you just get A. In particular, what is A cubed? Well, that's A squared, A, and that's AA, which is A squared, which is A. In other words, all the powers of A are just A. So, I guess positive powers. So, AN is A. In particular, what is A infinity? It's still A. So, limit n goes to infinity of A to the n. Well, that's limit n goes to infinity of A. But that's just a constant matrix, and that's A, which is 1, 1, 0, 0. On the other hand, let's calculate powers of B. So B squared, that's 1, 1, 0, 0 times 1, 1, 0, 0. And you calculate this and you get 1, 0, 1, 0, which is B. So B squared is also what's called idempotent, I think. And so B squared is B, and in particular, B to the n is B. So limit n goes to infinity of b to the n, that's b, which is 1, 0, 1, 0. Okay, that's good. In particular, we can calculate the product of the limits. So limit n goes to infinity of a to the n times limit n goes to infinity of b to the n. So that's literally AB, which is 1, 1, 0, 0, 1, 1, 0, 0. And you can calculate this to be 2, 0, 0, 0. So that's the product of the limits. Now the question is, what about the limit of the product? So now let's calculate. Well, we did calculate AB. That's 2, 0, 0, 0. But look, this is just a diagonal matrix. And the nice thing is, if a matrix is diagonal, to calculate any powers, you just raise the diagonals to that power. So AB squared, like this thing, AB squared would be 2, 0, 0, 0 squared, and that would be 2 squared, 0, 0, 0 squared, and that's 4, 0, 0, 0. In particular, AB to the n, that would be 2 to the n, 0, 0, 0. In particular, what happens when we let n go to infinity, you get a weird divergent matrix. Limit n goes to infinity of AB to the n, that would be infinity 0, 0, 0, 0. And in particular, notice the limits don't agree. Limit n goes to infinity of AB to the n, that's infinity 0, 0, 0, 0. And hopefully we can agree that 2 is not infinity, so those two things are not equal. Therefore, the limit of the product is not equal to the product of the limits. Alright, this is all in good. So just to conclude though, what if you don't like this infinity? What if we actually have a convergent matrix, if you want? Well, no problem. We can actually modify the example from before. Actually based on this trick. Again, remember A was, I think, what was it? 1, 1, 0, 0. Well, I have it here. 1, 1, 0, 0. B is 1, 1, 0, 0. Suppose you don't like the fact that you have infinity. No problem. Just redefine this. Just add an extra square root of 2 here. And there's a reason why I use it this way. Because then, what is a to the n? A to the n is 1 over square root of 2. 1, 1, 0, 0 to the n. Well, this power, well, the number just comes out, so that's not a big problem. 1 over square root of 2 to the n, 1, 1, 0, 0 to the n, which is 1 over square root of 2 to the n. And we just saw that if you raise this to any power, you get the same matrix. In particular, if let n go to infinity, this becomes 0 times this matrix, which gives you the 0 matrix. And similarly with b to the n, so b to the n goes to the 0 matrix as well. So in this case, limit n goes to infinity of a to the n to the b to the n just becomes the 0 matrix times the 0 matrix, which is the 0 matrix. On the other hand, let's calculate AB. AB, that is 1 over square root of 2 times 1 over square root of 2 of 1, 1, 0, 0. 1, 1, 0, 1, 0, all right, and then that's 1/2 times 2, 0, 0, 0, and that becomes 1, 0, 0, 0. And here's the cool thing, so this is a diagonal matrix, and if you raise this to any power, you just get the same matrix again. So AB to the n would be 1 to the n, 0, 0, 0 to the n, and that's 1, 0, 0, 0. So in particular, if you let n go to infinity, the limit here would be 1, 0, 0, 0, and therefore, even in the convergent case, we get that the product of the limit is not the limit of the products. Alright, so I hope you like this little limit extravaganza. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.